All right, third grade, this is chapter 19 math test. And as you can see, I have the test pulled up on my computer. And what you're going to want to have is your math book open up to chapter 19, a pencil, and make sure you have a highlighter. So what we're going to do is I'm going to take a look and I'm going to walk you through the test. I'm going to point out where you can find information from the book to help you take the test because it is an open book test, and we're going to highlight keywords to help you through the test. So for number 1, what is a straight? What is straight continues in both directions and does not end. So what I'm thinking is I'm going to take my highlighter and I'm going to highlight the fact that it's got to be straight. It goes in both directions and it does not end. Okay, so over here I have, let's go to page 384. So I'm going to go to 384, and here I'm going to see all of these vocabulary words. We have line, point, line segment, ray, and angle. So I need to figure out which one has that is straight, that continues in both directions and does not end. So I'm going to take a look at the definition and see if I can find the answer for number 1. Now I'm going on to number 2. What figure is formed by 2 rays with the same endpoint? So I'm looking for the definition of 2 rays with the same endpoint. Okay, so then I have a little different. I have square, angle, triangle, and a circle. Well, I know square, triangle, and circle are a shape, but I had to look for a definition of an angle, and I know the definition of an angle is on page 384. So I'm going to come here and figure out an angle and see if it matches with that definition. Number 3 is kind of like a riddle. I am part of a line. I have one endpoint. I am straight and continue in one direction. What am I? So I have one endpoint. It is straight. And it only goes in one direction. So is that a line, ray, line segment, angle? I'm looking for something that has an endpoint and goes in one direction, one way. So once again, I'm going to go to definitions on page 384 to take a look and see if I can figure out if it is a line, ray, line segment, or angle. Number 4, there is a picture. Emmy's teacher drew this figure on the board. Which best describes this figure? So right here, is this a angle, line, parallel lines, or line segment? And I've seen this figure before on page 384. So I'm going to open up to 384. I'm going to take a look and see if I can't match that figure to either being an angle, line, parallel lines, or line segment. Number 5, scroll all the way down here. The answer to a question asked by a teacher is 2 lines that never cross. What could the question be? So I'm trying to ask you guys a question. What's that question would be if someone in the class answered, oh, the answer is 2 lines that never cross. So what are 2 lines that never cross? Is it what are parallel lines? What is a line? What is an angle? Or what is an intersecting line? So I already know what a line and angle are from page 384, but parallel lines and intersecting lines are going to come from page 388. So you're going to take a look, intersecting lines, perpendicular lines, or parallel lines. Because remember, the question is, we're trying to figure out the question. But if someone in the class gives me an answer of, oh, it's 2 lines that never cross. Well, what did I ask you? Did I ask you what are parallel lines? What is a line? What is an angle? Or what is an intersecting line? Number 6. Ooh, I've seen this. Looks like it's got 2 lines that kind of have arrows in both directions. So it's an intersecting lines, a ray, an angle, or parallel lines. But I'm going to go and I'm going to take a look at page 388 because I think I've seen that figure before. So what is it? Intersecting, perpendicular, or parallel lines for number 6. And then actually for number 7, we're going to come back to the same page here because we're having a figure It looks like it's got two lines here, right? But is it a point, a line, parallel lines, or intersecting lines? And once again, I'm going to go to page 388 to find that answer. Now, for number 8, 9, and 10, to finish off the front side, we're talking about polygons and quadrilaterals. So we need to look on page 390 for the definition of both. So which figure is a quadrilateral? And remember, Miss Comer's talked about what a quadrilateral is. Remember, like a quad? So let's take a look on page 390. The top part has what's a polygon, right? But I'm going to go down to, right there, it's highlighted, quadrilateral. So quadrilateral, it has 4 sides and 4 angles. Quad, 4 sides, 4 angles. So if I go down to number 8 again, which figure is a quadrilateral? So I got to find something that has 4 sides and 4 angles, whether it's A, B, C, or D. Now number 9, which figure is not a polygon? Now do not get confused on that. So it's not. So that means 3 of them are polygons, but 1 of them is not a polygon. Let's go figure out the definition of a polygon, which is back on page 390. So a polygon is a closed plane figure with straight sides that are line segments. So look at it. A and B are polygons. They all have straight line segments, right, and they're closed. Not polygons, remember, they're open or they don't have any straight lines. So taking a look back at number 9, which one's not a polygon? Figure A, B, C, or D. All right, third grade, so now we're on the back. Remember, at any point in time, pause the video to answer the question, and then you press play to keep going on. So for number 10, 11, 12, and 13, we're going to take a look at these 4 triangles up here. Now, on page 393, we have so much information about triangles. Let's go back to 393 and review these. So triangles, you can name them by their sides. Remember, we have equilateral, isosceles, or scalene. Equilateral has all equal sides. So here, 2 centimeters, 2 centimeters, 2 centimeters. Now an isosceles has 2 sides that are equal, but one of them's not. So here you can see 3 centimeters and 3 centimeters, but then look at here, there's a 2 centimeters. So you have 2 of them that are equal, but the one of them's not. Now a scalene means that you have 0 equal sides. I have a 2 centimeter, I have a 3 centimeter, and then I have a 4 centimeter. So those 3 can describe a triangle based on its side: equilateral, isosceles, or scalene. But you can also describe a triangle by using its angles. So remember, we have a right angle, which is a perfect corner. We have an obtuse angle, which is bigger than a 90-degree angle. Or you have 3 acute angles. Remember, they're small angles. They're smaller than a 90-degree. So we need those definitions for 10, 11, 12, and 13. So for number 10, which triangle has a right angle? So I'm going to take a look and figure out which one has a right angle. I'm not looking at the sides. I'm going to look at the angles. K, M, L, or N. Number 11, which triangle has an obtuse angle? So which one has an angle that is bigger than a right angle? So slide back up here. K, M, L, or N. Remember, I'm looking at the angles. Number 12, what kind of triangle is figure K? So is an equilateral, scalene, right, or isosceles? So I'm going to go back up here and look at triangle K and take a look. Is it a right triangle? Talking about its angles? I don't think it is. So that means I'm going to look at its sides. So looking at its sides, is it an equilateral with all equal sides? Is it a scaling with all different side lengths? Or is it an isosceles that has 2 equal sides? Okay, then coming down to number 13, which figure is an equilateral triangle? So now we're looking at the sides again. So coming back up here, which triangle up here, K, M, L, or N, has all equal side lengths? Okay, then we have 14, 15, and 16 are talking about the shapes over here. L, M, N, and P. You can see I kind of also drew some things on the side here. So number 14, which figure has 4 equal sides and no right angle? So kind of to remind myself, I went over here and I actually drew a right angle, but I'm looking for one that does not have a right angle. Does not. So meaning it cannot have this. So actually what I'm going to do to tell myself, I'm looking for something that does not have that, right? I'm going to cross that out. It does not have a right angle, but also has 4 equal sides. Okay, number 15. Which figure has 4 equal sides and 4 right angles? So 4 equal sides and 4 right angles. So I am looking for something that does have a right angle, but 4 equal sides. Number 16. Which figure has no pairs of parallel sides and no right angles? So I drew 2 pictures that I'm looking for. I know that a right angle is right here, but of course remember I said it can't have that, so I'm going to cross it out. So it can't have a right angle, and it's saying it has no pairs of parallel sides, so it can't have these. So I'm looking for something that does not have any right angles and does not have pairs of parallel sides for number 16. Now for 17 and 18, it's actually a review of multiplication. So when you look here, Peter used labels, multiples of 2 and multiples of 3 for the sets of his Venn diagram. I would either grab a separate sheet of paper or you can draw on over here, but it's way too small for me. So I'm actually going to draw. I'm going to have my own Venn diagram here. So let me grab that. Okay, so on the left side, I have multiples of 2, and on the right side, I have multiples of 3. Remember, where they are on the outside is where they're different, but then where they overlap is where they have the same. So multiples of 2 is and multiples of 3 is multiplication. So what I'm going to do, I'm going to go up to 10. So I'm actually going to do my Venn diagram first before I go back and do number 17 and 18 talking about it. Because number 17 says which number could be in the area where the sets overlap. And number 18 says which number would not be in the area where they overlap. So I'm going to actually do both of them first, do the multiples of 2, multiples of 3, and I'm going to go from there. So multiples of 2, I'm going to multiply it by 2, and I'm going to go kind of by numbers. So 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. 2 times 6 is 12. 2 times 7 is 14. 2 times 8 is 16. 2 times 9 is 18. And then 2 times 10 is 20. Now I just did the multiples of 2, right? Now let's go over and do the multiples of 3. Because I don't know what's going to be overlapped yet until I do multiples of 3. So starting over again, we're going to go to 10. So 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. 3 times 7 is 21. 3 times 8 is 24. 3 times 9 is 27. And then 3 times 10 is 30. So I have my Venn diagram done. Or wait, do I? No, because I got to take a look and see what would overlap. So I got to see now, are there any numbers that are both on the multiples of 2 and multiples of 3? So taking a look here, do we both have 2s? No. Do both have 4? No. But do both have 6? Yeah, so I'm actually going to erase the 6 from my 2 side and erase the 6 from my 3 side and bring them over. Okay. Do both have 8? No. Do both have 10? No. Do both have 12? Yeah. So once again, I'm going to erase it from my 2 and erase it from my 3 and bring them together. Okay, do both have 14? No. Do both have 16? No. Do both have 18? Yes, so I'm going to bring 18 over. And then do both have 20? Nope, and then we stop on 2, so I don't need to keep going on 3. Okay, so let's go back to the questions on number 17. Which number could be in the area where the sets overlap? 3, 9, 12, or 15? Because I think we have the answer. We found the answer for number 17. It's right there in front of us. Okay, now number 18. Which number would not be in the area where the sets overlap? 6, 9, 12, or 18. Remember, I'm looking for one that's not in the overlapped area. Okay, then. So that is the end of Chapter 19 test. Remember, you can go back at any time, take a look, replay the video, see what you maybe understood or didn't understand. Make sure you have all of your questions answered from 1 through 18.